Hi everyone, I am Rajitha, working as an Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today, we're going to see about Hamiltonian Circuit Problem. The Hamiltonian Circuit Problem asks whether it is possible to start from vertex, visit every other vertex exactly once and return to the starting vertex. This problem is important because it is connected to many real-world applications such as route planning, network design, logistic, and optimization. The puzzle of the Gold Hadron. The history of the Hamiltonian circuit problem begins with Sir William Rowan Hamilton in 1856. He invented a mathematical game called the Icosian games. In this game, players had to travel through every vertex of a game exactly once and return to the starting point. Although it was designed as a puzzle, it later became an important mathematical problem. This puzzle inspired researchers to study path and cycle in graphs. What is a Hamiltonian cycle? A Hamiltonian cycle is a cycle in a graph that visits every vertex exactly once and then return to the starting vertex. A graph that contains such a cycle is called the Hamiltonian graph. For example, imagine a tourist visiting every city exactly one time and then returning home. The tourist should not visit any city twice. This is similar to a Hamiltonian cycle. The main objective is to ensure that every vertex is included exactly once in the cycle. The challenge, NP completeness. One of the reasons the Hamiltonian circuit problem is famous is because it belongs to the NP complete category. In computational complexity theory, problems are classified into P, NP, and NP complete classes. The Hamiltonian circuit problem belongs to NP complete, which means it is very difficult to solve efficiently. Currently, no polynomial time algorithm is known for solving all Hamiltonian circuit problems. As the graph size increases, the difficulty increases rapidly. Why it is so hard? The Hamiltonian circuit problem is difficult for several reasons. First, it is difficult from the equivalent circuit problem. An equivalent circuit visits every edge exactly once, while a Hamiltonian circuit visits every vertex exactly once. Second, small changes in a graph can completely change whether a Hamiltonian cycle exists. Third, a brute force approach requires checking many possible paths. For a graph with n vertices, the number of possible paths grow approximately as n factorial. This enormous growth makes the problem computationally expensive. And real-world connection. The Hamiltonian circuit problem has many practical applications. One important example is the traveling salesperson problem. In TSP, a salesperson must visit every city exactly once and return to the starting city. A Hamiltonian cycle forms the basis of this problem. Other applications include delivery route optimization, vehicle routing, circuit board manufacturing, DNA sequencing, robotics path planning. Where special cases where solutions are guaranteed. Although the general problem is difficult, some special cases guarantee a Hamiltonian cycle. The first is Dirac's theorem. It states that if every vertex has a degree greater than or equal to n divided by 2, then Hamiltonian cycle definitely exists. The second case is planar for connected graphs. These graphs are always Hamiltonian. The third case is certain grid graphs which have specific structural properties. These special conditions help researchers identify graphs where solutions are guaranteed. The algorithm approaches. Several approaches are used to solve Hamiltonian circuit problems. The first approach is backtracking. Backtracking explores different paths systematically and remove paths that cannot lead to a solution. The second approach is heuristics. These methods provide approximate solution and are useful for large graph. And the third approach is specialized algorithm. And the The ongoing quest, the Hamiltonian circuit problem, continues to be a major research topic. It plays an important role in complexity theory and algorithm design. Researchers use it to understand the limits of computation. Studying this problem helps improve optimization method and problem solving techniques. So we conclude, over time, it become one of the most important problem in graph theory and computer science. The problem asks whether a cycle exists that visit every vertex exactly one and return to the starting point. It application and routing, optimization, logistic, and network design make it highly relevant today. This is a mind map for a Hamiltonian cycle. Thank you.